Okay, so here they're doing what? Tossing a coin twice and recording the ordered pair. So we're going to record this, where NH is the number of heads and NT is the number of tails. So what is the sample space? So it's going to consist of ordered pairs, because this is what we're recording. So you could get 2 heads and 0 tails. You could get 1 head and 1 tail, or 0 heads and 2 tails. Of course, you can't get like 1 comma 2 won't be there, because that would be more than tossing it twice. If E is the event that NH plus NT is even, and F is the event that NH plus NT is less than 1, then E is, when we add these two, we get an even number. So this is in there. When we add these two, we still get an even number. When we add these two, we're always going to get an even number. So E is actually equal to S, and F is that the number is less than 1. It's never going to be less than 1, because this is all the tosses, and we're tossing it twice, so it can't be less than 1. So F is the event that this is less than 1, means F is the empty set. So E is a certain event, and F is an impossible event. Now, so I just finished putting up some set videos, so I assume that you know about sets. And so here they say that since events are sets, we can apply the set operations, union, intersection, and complementation or complement to them. Thus, given events E, F, and a sample space S, we can form new events. For example, E intersect F is a new event. Now, remember, an event is a subset of the sample space. So if E is an event, it's a subset of the sample space. If F is an event, it's a subset. So they're both sets. So we can take the intersection of them, and the intersection will be a new event, because, for example, here's the sample space, the square, and then E is an event and F is an event. The intersection is here. That's also a set, and it's also a subset of S. Therefore, it also is an event. Same thing with E union F. E, F, the union is a set, and it's also going to be a subset of S. So it's also an event. So this is a new event. This is a new event, and E prime is also a new event. Okay, so the event E union F consists of those sample points that belong to E or to F. The word or is used in the inclusive sense defined in section 1.2. The event E intersect F consists of those sample points. Okay, so we know this. So we have the following. Stating that E union F occurs is equivalent to stating that E or F occurs. So if E or F occurs, then E union F occurs, and if E union F occurs, then either E or F or both have occurred. Stating that E intersect F occurs is equivalent to stating that E and F both occur. Right? So if we say E intersect F, it means something in here happened. That means that both E happened and F happened. So E and F both occur. And stating that E prime occurs means that E did not occur. Stating that E prime occurs is equivalent to stating that E does not occur. Okay, let's look at an example here. An experimenter tosses a die and records the number on the top face. Let E be the event that the number is divisible by 3, and let F be the event that the number is odd. So what are the numbers that are divisible by 3? And what are the numbers that are odd? Right here, right? So the event that the number is divisible by 3 and odd is the intersection of these. In other words, the intersection is the same as the word and. So E and F is the intersection. It's the only time the event that the number is divisible by 3 and odd, that's only a 3, right? And that's E intersect F. The event that the number is divisible by 3 or odd is this. So or is union. The event that the number is not divisible by 3 is the things that are not in E. So 1, 2, it's E complement. Okay? So verbal expression E or F occurs, set interpretation E union F. Verbal expression E and F occur, set interpretation E intersect F. Verbal expression E does not occur, set interpretation is E prime. If two events have no common sample points, then the two events cannot both occur on any single performance of the experiment. Such events are said to be mutually exclusive or disjoint. For example, here, E and F are what? Getting an even number and getting an odd number. So if you roll a die just once, a single occurrence, then you can't get both an even number and an odd number. And the reason is that these have nothing in common. Okay? These two events are called mutually exclusive. So E and F are called mutually exclusive events. They cannot happen at the same time. It means that when you think of them as sets, they have nothing in common, or their intersection is empty. So symbolically, E and F are mutually exclusive or disjoint if E intersect F is equal to the empty set. The notion of mutually exclusive can be extended to more than two events. We can talk about n events as mutually exclusive, and the meaning will be if no two of them have any sample points in common. So if you take, you have to have all two-wise pairs of them have nothing in common, then we say that the n events are mutually exclusive, and no two can occur on any single performance of the experiment. So it's like this. No two of them have anything in common. Okay, that's the end of section 8.1. So you can look at these exercises if you want.